Following on from the previous video, we got to this stage here. Hang on. We were trying to work out the area between 3 and 9 here. So we were trying to work out this area here of this function here. And then we got to this stage here. Where the area is approximately this whole thing here. Now, when you have a summation like this, it is a k that's changing about. It is the k that's moving about. So this thing here, you see, when you look at this, k only appears in here. So at the moment, you've got the height of the rectangle here times the delta x here. So this thing here is a constant. So you can actually take it out here because when you look at a summation like this, you've got this block times this block here. And when you have a summation like this, it is a k that's changing about. So k only appears in this block here. So this here is really a constant. So you can actually take the whole thing out. Okay, then that will then give you this. Okay, so when we were trying to find out the area of this rectangle here, when we were trying to find out the area of this rectangle here, to find out the area, we needed to know the height, and then to find out the height, we would put this thing back into the original function, and then this whole thing here would then give us the height. Okay, so remember, we would put this into the original function. Okay, and then this here would then give us the height of that rectangle. So when you get to this stage here, hang on. So when you get to this stage here, so this here is a constant, so we can take it out here. So now when you look at this stage here, what it's saying here is that you've got to put this into the original function. So remember, the original function was this. So what this means here is that we've got to put this into the original function here. So we've got to put this. So really, we've got to put this into this x here, and then this whole thing here would represent this whole thing here. Okay, so when you look at this here, you've got to put it into the original function. Well, the original function being this, then it would then take us to this. Okay, because it's saying here, put this into the original function. Well, the original function is this thing here. So we've got to put this into this x here. Okay, so the 3 here is this 3, and don't forget, because we're putting the whole thing here into the x, then that's us putting this whole thing here. So this squared here is this squared here. The 2 here is a 2 here. Okay, so this, from here it will then take us to here. Okay, so now just use algebra. Multiply out the brackets. Multiply out this thing here. So it's really 3 plus 6k over n times by itself plus 3 6k over n here. So this times this here would give us 9. This times this here would give us 18k over n. And then later on, we've got another one here, exactly 18k over n here. Merge these two together, that would then give us 36k over n, and then we've got this times this, that would then give us this, blah blah blah, multiply, well this then becomes this. Okay, and then what? And then, oh yeah, and then this times this would give us this, this times this would then give us this, this times this would then give us this. So it's just a matter of tidying up now. And then merge this with this. That would then give you 29. And then what? And then, oh yeah, and then we can break into here. So that would then give us this summation of well, this will then give us this, and then that will then give us this. Okay, so this whole thing here is exactly the same as this thing here. Okay, and then this is a constant, so it's just n times a constant. So that will then give us this. So this thing here will then give us this. This thing here would then give us this, because this is a constant here. Okay, it's a constant here. So because it's a constant, you can take it out. So that will then give us this, and the same goes over here. This here is a constant, because when you look at the summation here, it is the k that's changing about. It is just this thing that's changing about. The rest here is just a constant. So take this fraction out. Take it out here. Okay, so now we can just concentrate on finding out k squared and concentrate on finding out k. Okay, so using the formula here, this thing here then becomes this. Okay, and using the formula, this would then become this. Okay, so this here stays the same, and this here stays the same. So, and then it's really blah 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 now. It's so this stays the same, and then we would multiply this. So this whole thing here becomes this, because you've got a fraction here times another fraction here. So it's top times top, bottom times bottom. So the thing is, this thing gets cancelled out, and then this divided by 2 will give you this. Well, n would be that. Blah blah. This gets cancelled out with one of the n's here, and then this divided by 6 here would give you 18. Blah blah. So this thing here becomes this thing here. Okay, and then this times this would then give you this, and then multiply this out. This times this times this times this times this would give you this. Okay, and then this times this times this hang on, and then merge these two together. That will give you 3n. Sorry. And then, so this times this here will give you 36n squared. This times this here would give you 54n. Okay, and then this times the 1 here would give you 18. Okay, and then oh yeah, and then merge these two together. That will then give you this, and then it's really blah blah blah. And then what? Hang on, let me think. And then this times this here would give you this. This times this here would give you this, and then this times the whole thing here would give you this thing here. Okay, and then so at the moment we've got area is approximately this thing here. Now we are going to make n head towards infinity, meaning we are going to have we are going to increase the number of strips to infinity. So because we are taking the limit, then the area is no longer approximately. The area is precisely this thing here. Okay, because the minute we take the limit, meaning that we are going to have an infinite amount of strips, then the area becomes the true. Well, this here is approximately. The minute we take the limit, it becomes precisely. So the area is precisely this whole thing here. Okay, so and then blah blah blah. Using one of the theorems on limits, we can do this here. So that will then take us to this, and then looking at this here, as n tends to infinity, this here will head towards 0. Okay, as n tends to infinity, so this here is a constant, so it becomes this thing here. As n tends to infinity, this is zero here. So now break this fraction up into two. So here you've got a fraction here. Break it up into two fractions. So you've got one fraction here, and then you've got another fraction here. Okay, and then break the limits. Break into it. So this will then become this. This then becomes this. You see, when you look at this here, you've got a bubble here divided by another bubble. So as n tends to infinity, this bubble here will get a lot bigger than this bubble here. So eventually you're going to have something that's really small divided by something that's really big. So something small divided by something that's really big, then overall this whole thing here tends to 0. So this whole thing here tends to 0. This thing here, well, this thing here will tend to 216. So now it's just blah blah. The whole area here equals 714.